Okay, so this is the second part of the problem that I had done previously. So what I found in the previous problem is the circuit was given, this current was not given. I had to find this out. So now I will start from here. I have this current. I need to find out what is the power supplied by the current source. So, and also what I have to find out is basically that's the thing I have to find out. But what I will do, I will check the power supplied and power dissipated. So I have this current 0.8 amps, and the total current here is coming from, in this direction it's 2.4 amps, so in this direction the current is 1.6 amps. So that I have. So in order to find the power supplied by the current source, what I need is P is equal to VI, we know. So we need to find the voltage drop across the current source. So we know the current through this branch, so the total drop will be, that will be the drop across the current source, because this is 20 ohms and 10 ohms in series is coming in parallel with the current source, this 20 ohms and this 10 ohms. So we can find the drop by 0.8 is the current here, I, and R is, so V is equal to IR, and this is the, these two are the R's, so 20 plus 10, so that's 30, and times I again, so I is 0.8. Sorry, I will be 2.4 because this is the current supplied by the current source, so the current of the current source basically, so 2.4. So once I do it, it becomes 57.6 watt. So that is the power supplied by the current source. So that's there. Now let's see what are the dissipated powers. So dissipated power, first of all, the resistance 20, P20 and P10, if we calculate these two, this one and this one, we will get current is I, so I square R, it will be I square R, so I square here times 20 plus I square times 10, or I could have just written 0.8 square times 30. So this one is 19.2 watt, so that's there. Now I have this current, and instead of finding the current through 90 ohms and 10 ohms, what I can do, I can just find the equivalent resistance, and then the total current through that resistance will be the same as 1.6 amps. So the equivalent resistance here is 90 and 10 parallel, so that will be 90 times 10. I had to do this in the previous one as well, plus 10, so that's 9 ohms. So basically I will just draw this part. This part becomes, this is the 1.6 amps current, 6 ohms resistance, that one, and this one becomes just one resistance now, 9 ohms. So the current here is also 1.6 amps. So if I want to find the total current dissipated by these two resistances, that will be P, I don't know, let's say R here. These two are basically, these two R's. So 1.6 I square R, P across the resistance, any resistance, the dissipated power is I square R. So I square, the same current I square, and I can just add these two currents, so times 15. So that one comes to 38.4. This is the dissipated power dissipated across 6 ohms and 9 ohms. Same current, so I have just added the resistances here, 6 plus 9, and then I square R. So the total dissipated power is 38 plus 4, 38.4 plus 19.2. If I add them, I will get the supplied power, which is this one, 57.6 watts. So that's what it should be. The supplied power should be equal to the dissipated power. So this one plus this one is equal to the supplied one, which is this one.